Hola, me llamo Yaman, and for your Spaceship Earth Science unit, I wanted to talk to you about rocket propulsion. Rocket propulsion is super cool because you can use it to go to space like an astronaut does, or you can use it as an amateur and enter some fun competitions. Right here, I drew the basic chemical reaction for rocket propulsion. It's called the combustion reaction. What happens is you use a source of fuel and some kind of oxidizer to create enough force that's called thrust, and that thrust launches things into the air. This type of fuel is called methane. It's a very common liquid fuel. There are also combination fuels or just pure solid fuels. And what we're going to be working with today is a solid fuel. The type of solid fuel that's really common is nitroglycerin, and things like aluminum powder, it's a metal, can be added to enhance the performance. I actually recently found out that you can also use polymers, which is something I work on in my research, as a source of fuel as well. But today, we're going to be using uncooked pasta as our solid fuel. Our reaction today might not get us to the stars or to the moon, but it'll get the basic principles of the chemistry across. I'm at home today, but I'm working with fire, so I have a fire extinguisher on hand. I'm also going to be potentially, very small chance, building up pressure in the system. For that case, I need to wear eyeglasses and a lab coat. And now we're ready to start our reaction. The materials I need for this reaction are my solid fuel source and something that'll produce my oxidizer. So my solid fuel source, like I mentioned, is this uncooked pasta. And to create my oxidizer, I'm going to create oxygen gas through a reaction with hydrogen peroxide and active dry yeast. I'm going to fill up my container more than halfway with the hydrogen peroxide. And I'm going to add a small amount of the yeast. This creates a lot of bubbles, as you can see, which is oxygen gas. And my cap here is not going to be sealed so that any pressure can escape if it needs to. So I'm going to place a piece of pasta over the hole in the cap, and I should get ignition. What's happening here is that the oxygen is passing up through the hole into the hollow part of the pasta, which is then igniting and acting as a rocket would. We don't get propulsion because there is no direction to this force. And that is how you can model rocket propulsion. You might be wondering why today's video is so much shorter than usual. That's because I am currently working specifically with the 5th graders at Irish Elementary Bilingual School. Because Irish Elementary has their Spaceship Earth Science program unit this month, I decided I might as well reach out to NASA and see if anyone would want to come talk to us. Several scientists got back to me, and they'll be joining us for this month's meeting. So 5th graders at Irish Elementary School here in Fort Collins, prepare your questions, and you're going to meet some real-life NASA scientists. See you soon.
8, 7, 6, 5, 4. Engine ignition, 2, 1, 0. And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1 Atlas V is now supersonic.